last week, we have discussed about application of separable differential equation. So for today, we continue our discussion on the application of linear differential equation. Okay, so before we start our discussion today, any question about the last topic? Ada soalan? Untuk grup CEE 2221C ada soalan tak? Boleh dengar suara saya?
Dengar Puan.
Dengar ada soalan untuk topik yang lepas? Tak ada. Alright, so kalau tak ada, kita boleh teruskan untuk topik kita hari ini. Alright, so today we discuss about application of linear differential equation. So linear differential equation we can apply in mixture problem and RL electric circuit. So for this electric circuit, actually we have two types of electric circuit that we can apply linear differential equation. The first one is RL, which is the electric circuit involving resistor and inductor, and the other one here is RC. Okay, electric circuit involve resistor and capacitor. Okay, so katakan you ada electric circuit involve three components which are R, C, and L, resistor, capacitor, and inductor. So that one we use second order differential equation. So yang tu nanti kita akan discuss later. Okay, right. So now we look at mixture problem. So mixture problem, this one is a linear application. So you can read this text. So in this problem, we will start with a substance that is dissolved in a liquid. Okay, dissolved in a liquid. So liquid will be entering and leaving a holding tank. So this is means that we have a tank and the liquid with a substance is enter and exit at the same time. Dia masuk dan juga keluar pada masa yang sama. Okay. So the liquid entering the tank may or may not contain more of the substance dissolved in it. So liquid leaving the tank will of course contain the substance dissolved in it. So if Q of T give the amount of the substance dissolved in the liquid in the tank at any time T. So here we want to develop a differential equation. Okay, so based on this information, we will develop the equation, which is the equation for quantity of substance at any time T, Q of T. So let's say we have a brine water, which is the water dissolved with salt. So we want to calculate the quantity of salt in a liquid. Yang tu maksud je. So here we need to find Q of T ataupun we need to develop the equation of Q of T. Okay. Alright, so look at this equation. So the equation is based on this one, which is rate change of substance at any time T, which is dQ dt. Equivalent with rate in. So rate in is rate at enters the tank and rate out. So rate out is a rate that exits the tank. Okay, so we have this tank. So kita ada tangki kat sini. Okay, so the mix ataupun contoh brine water. Air garam kita masukkan. So masukkan, kadar kemasukan kita akan kira jugalah. So dia ada flow in and concentration in. Maksud flow in tu adalah kadar kemasukan cecair. Flow dia. And then ada C in. C in adalah quantity garam yang kita masukkan sekali. Okay, tu kita panggil sebagai C in. Alright, so in this tank we have a liquid. Katakan kita ada water, pure water ataupun we have oil pun boleh. So ini liquid lah dalam tangki ni. And then at the same time, it has a flow out. Okay, dia mahu keluar dan juga concentration out. So concentration out means that the quantity of salt exit with the liquid. Okay, dia keluar pada masa yang sama. Okay, so we have flow in, C in. So flow in, C in. So this one is about rate in. So rate in is flow in times C in. And for rate out, ada rate out, ada pengeluaran. So rate out it is equivalent with flow out times C out, concentration out. Okay. Alright, so this one is a rate in. So tengok rate in. Rate in is a flow rate of liquid entering. So we call it as a flow in, multiply with concentration in. So concentration in means that concentration of substance in liquid entering. Yang tadi kita masukkan tadi. Okay. And then for rate out, we have a flow out. So flow out multiply with concentration of substance in liquid exiting, which is C out. So in order to calculate for C out, we use this formula. Ini formula untuk concentration out. Okay, amount of salt in the tank at any time T over or divided by volume of water in the tank at any time T. So it is also equivalent with Q of T. So we state Q of T because we do not know the quantity of salt exit from the tank. Okay, so we take it as a Q of T and over volume V naught. So volume yang sedia ada dalam tangki itulah. Okay, V naught at T equal to 0, which is the liquid already in the tank. Okay, plus with flow in minus flow out. So this is a different flow between in and out, multiply with T. So this is the formula for concentration out. Okay. Alright, any question? Group dalam web ada soalan? Tak ada ya? Okay, so kalau tak ada kita tengok contoh. Right. Okay, so we look at this example, example 6. Alright, so in this example, a tank initially contains 40 liters of pure water. So bila dia kata pure water, means that there is no any substance inside water. So here we can say that V naught volume is a 40 liter. And ni L takut nanti ingat benda ni. Oh, this one is L, 40 liter. And quantity of substance at T equal to 0 is 0. Maksudnya tak ada kandungan apa-apa bahan dalam water tu sebab dia kata pure water. So next, a brine containing 0.5 kg salt per liter flow into the tank at the rate 12 liter per minute. So this one 0.5 of kg of salt per liter. This one is our C in. Concentration in, so concentration in here is 0.5 kg per liter. Okay, so maknanya setiap liter dia masukkan 0.5 kg garam dalam cecair tersebut ataupun dalam kandungan air garam lah. Okay, and then into the tank at 12 liter per minute. So this one is our flow in, and then the mixture stirred. And simultaneously, the mixture flow out at 8 liter per minute. So this one is our flow out, 8 liter per minute. Okay. And then we need to estimate the amount of salt in the tank after 10 minutes. So here we need to find the quantity of salt after 10 minutes. Berapa banyak kandungan garam yang tinggal dalam tu selepas 10 minit. Okay, so in order to find the quantity of salt after 10 minutes, first we need to find the quantity of salt at any time T. Okay, so this one is very important. So kalau kita tak dapat Q of T, kita tak boleh nak estimate untuk 10 minutes after ataupun 20 minutes after. Okay, so here we need to find this Q of T. Alright. So in order to find Q of T, we need to develop the equation. So how to develop the equation? So the equation is based on this one, dq dt, equivalent with rate in minus rate out. Okay. Ini tangki dia. Okay, so dalam tangki ni ada pure water. So the volume of this pure water is 40 liter. 40 liter and there is no any substance. So we can say that Q at T equal to 0 is 0. Okay, so flow in dekat sini. Flow in dia berapa tadi? 12 liter per minute. and then C in is 0.5 kg per liter. Okay, untuk C out, flow out dekat sini, F out is berapa tadi? 8 liter per minute. And C out kita kena gunakan formula tadi, which is Q of T over V naught plus difference of flow in and flow out multiply with T. Okay? Right, soalan tak? Okay tak kelas? Macam marah je. Okay. Okay, so now kita set up the equation. So the equation here is dq dt multiply with rate in. So rate in is flow in multiply with C in equal to rate in, which is 12 times 0.5 multiply minus with rate out. So rate out is 8 multiply with Q of T over V naught tadi apa? Volume dia 40 plus 12 minus 8, which is flow in minus with flow out. T. Kat sini T yang ni plus. Alright, so here we have 6 multiply with berapa? 8 QT. Yes, any question? Plus 40, yeah. So this is the equation for this mixture. Okay. Boleh ada soalan? Rate out mana? This one. Okay, so 8 it is the flow out. So this one is C out. So C out ni kita gunakan formula yang lain, which is Q of T equal P outside at any time T over volume plus difference of flow in and flow out multiply with. Okay, so this one is out. Yes. Okay, boleh ada soalan tak? Faham tak? Belakang boleh ikut? Alright, so next, based on this equation, we also can write it as kita juga boleh tulis dia sebagai dq dt minus 8 over 4t plus 4t q of t equivalent with 6. Okay. So mana yang tak perasan, actually this one is a linear differential equation. So yang ni adalah linear differential equation. Mana? Bawah ni? Tambah. Okay, tambah. So this one is about linear differential equation. Okay. Alright, so based on linear differential equation, we have two steps. The first step, we need to find the integrating factor. And the other one, we need to find the general solution. Okay, so bila nak cari integrating factor, you need to identify for P. Kan kita ada PX and QX kan? Ingat kita? Kita kena identify that two things and then we can find the integrating factor and the general solution. Okay, untuk part yang ni ada soalan tak? So what is a rate in and flow in? So rate in and flow in. Rate in is a flow in times C in. Okay, so minus with flow out. Multiply with C out. Concentration out. Okay, boleh? Okay. So next, kita selesaikan dekat whiteboard. Okay, tadi kita ada equation ni. dq dt plus 8 over 40 plus betul 40 q of t equivalent with 6. Okay, so kalau you tengok kepada linear differential equation, so originally we have dy dx, ingat lagi? And then plus p of x y, and then equivalent with qx. Okay, so this one we can say that this yang ini as our p of t, kita gunakan t lah sebab variable dia adalah q and t. So we use t, and this one is our kita letakkan sebagai small q. Sebab nanti you confuse dengan q of t, which is quantity of salt. So qt. Okay. Okay. Right, so in order to solve for the linear differential equation, we have two steps. Ingat tak step dia apa? Terima kasih kerana jujur. Okay, first we need to find integrating factor. Integrating factor, apa formula dia? I of x equal to exponent integral p of x dx. Okay. And next step, we need to find general solution. General solution. So general solution is y of x equivalent with 1 over, ini kita recap yang kita dah discuss linear differential equation. 1 over integrating factor multiply with apa? Integral. Oh, tak pernah belajar je. Ha? Apa dia? This one So ini adalah how we solve for linear differential equation. First we need to find integrating factor. Second we need to find the general solution based on their own formula. Okay. So this means that in this situation we also need to find the integrating factor. So integrating factor untuk case yang ini adalah integrating factor. This one is I, kita guna T equivalent with exponent integral of our P of T is 8 over 4T plus 4T. Okay, so integrate respect to T. So 8 over 4T plus 4T, 40 plus 4T. So with this one we can simplify. Then we have exponent integral of, boleh simplify tak ini? Apa? 2 over 10 plus T. Boleh simplify berapa ni? Simplify 4. Yang lain ni tak tahu nak cakap.
Maksudnya tiga balik kot.
Okay, so integrate this one. We have exponent 2 natural log berapa? Integrate 2 over 10 plus t respect to t. Macam first time nampak macam ni kan. Okay, so exponent this one, these two we can bring as a power for 10 plus t. So here we have exponent natural log of 10 plus t to the power of 2. So exponent and natural log we can simplify. Then here we have 10 plus t to the power of 2. So this is our integrating factor. Okay, so integrating factor for this case, which is I of t. Okay. Apa tak ni? Boleh lah. Okay, so next, we find the general solution. So general solution for this case is about Q of t. So Q of t is equivalent with 1 over integrating factor that we have obtained in the first step. Okay, I of t multiplied with the integral of Q of t. So our Q here is 6. Multiply with integrating factor respect to t. 1 over 10 plus t, the whole thing to the power of 2, multiply with 6 times 10 plus t to the power of 2 respect to t. Okay, so we solve for this one. 6 over 10 plus t squared integral. This one expand. So expand inside here we have 100 plus 20t plus t squared respect to t. So integrate, then here we have 6 over 10 plus t to the power of 2. So integrate yang ini. So we have 100t plus 20t squared over 2. 10t squared plus t to the power of 3 over 3 plus c. Okay, c is any constant. Nampak?
Oh, inilah buat ini. Jadi kita berdua.
Apa? Any questions? Jadi doktor dah sangat. Dan you?
Agak dari saya.
Boleh masuk solat tadi. Okay, kat mana yang kita tuju?
Ya.
Biasa. Ya, baik.
Doktor sekali di bawah nak sangat. Okay, nak saya explain balik ke?
Ada boleh. Baik.
Okay, so untuk group 2221C, any question? Ada soalan? Okay, boleh. Boleh kita teruskan? Boleh. Okay, so now we have this. So therefore, quantity of salt at any time t or quantity of substance at any time t is 6 over 10 plus t squared. multiply with 100t plus 10t squared plus t power of 3 over 3 plus c. Okay, so this is a general solution. Okay, so tadi untuk first in the example it says that we have a pure water at t equal to 0. So we can use this initial value to find our c. So kita boleh gunakan yang ini untuk dapatkan c. Okay, so ini kita panggil sebagai initial value. Initial value. Alright. Okay, so back to this one. So we entered ataupun we substitute t equal to 0. So here we have q at 0. Okay. Equal to 6 over 10 plus 0 to the power of 2. Multiply with 100 times 0 plus 10 times 0 squared plus 0 over 3 plus c equal to 0. Okay. So you cari nilai dia. So inside here semua kita akan dapat kosong. So 0 multiply with 6 over 10 squared, we have 0. So here c equal to 0. Right. So therefore, quantity of salt at any time t is 6 over 10 plus t squared multiply with 100t plus 10t squared plus t power of 3 over 3 plus c plus 0. Okay, so tak perlu kita letak plus 0 ni, no need lah sebab dia memang dah kosong kan. Okay, so this means that this one is the equation that we have developed from the information given, which is cube of t equivalent with 6 over 10 plus t squared times 110 plus 10 t squared plus t cube over 3. Okay, so untuk after 10 minutes, so how to find the quantity of salt after 10 minutes? Yes, we substitute t into 10. Okay, so after 10 minutes, okay, berapa jawapan dia?
8.3.
Ha? 0.3 apa?
8.3.
8.3.
Tahu.
Betul. Okay, kira-kira. Plus 35. So the quantity of salt after 10 minutes is 35 kg. 35 kg. Okay, so this is the answer. Yeah. Okay, boleh? Okay, settle. So, nilai dia, jawapan dia 35 kg. Okay, any question about this example? Tak ada? Belakang okay? Alhamdulillah. 221C, okay?
Okay, Mida, okay.
Okay, alright, good. Okay, kalau okay kita tengok example yang seterusnya. So the next one is about electric circuit. So this one is about mixture problem. You apa? Elektrik kan? Tak boleh kelentong kan ni.
Lagi tengok Lita.
Lagi pernah tengok Lita. Dia ada benda
Okay, can we start? Alright, so now look at this one. So this one is about electric circuit. So yang tadi tu adalah mixture problem. So now is about electric circuit. So electric circuit is an application of a linear differential equation. Okay, so for this one in the diagram, it is about RL circuit, which is the circuit involve a resistor and inductor. Okay, so it can be any lah. So kalau yang melibatkan dua komponen, kita gunakan first order. Kalau yang melibatkan tiga komponen, kita gunakan second order. Alright, so now look at this one. Aku dah nak cerita dengan bola elektrik ni.
Oh ya.
Laki, kalau I salah tolong betulkan
Jom.
Siap.
Alright, so look at this one. The RL circuit shown below has a resistor and inductor connected in series. So a constant voltage V is applied when the switch is closed. Okay, so bila switch close, so the current akan berjalan lah. Betul? Okay, so this one is a symbol of electric circuit, which is this one is a R resistor. Kalau dalam bahasa Melayu apa perintang kan?
Betul.
Yang macam halus kan tengah-tengah tu. Warna, ya ke? Dia ada warna perang kan tengah-tengah tu. Betul ke?
Ada garis warna-warna.
Dia ada garis, I ingat.
Jadi.
And then inductor L, so this is a symbol for L, inductor. And this one is our voltage. So voltage is our energy lah, total energy. So voltage ni biasa ada pada apa? Bateri. Bateri, power dan sebagainya. Sebab dia yang akan memberi energy ataupun power kepada lita ni. Alright. Okay, so in this case, we have about two variables that involve, which are VR and VL. Okay, so this one, the variable voltage across the resistor is given by VR. So VR is about IR. So I dekat sini adalah current. So I is a current. So current I equal to dQ dt. Okay, so R is a current is a rate change of Q. Q apa? Charge at any time t. Alright. Okay, so next we have a second variable. So second variable involve inductor. So the variable is given by V sub L. So it is equivalent with L di dt. Okay, which is inductor multiply with the rate changes of current at any time t. Okay, and then based on this variable, we use Kirchhoff law. So kita ikut Kirchhoff voltage law. Pernah dengar ya? Okay, so it says that the directed sum of the voltage around a circuit must be zero. So this result in the following differential equation, which is Ri plus L di dt equal to V voltage. Ataupun it is about Ri tadi apa? VR plus VL equal to V. So VR, VL is a variable involved, which are IR for VR and VL is L times di dt. Okay, so based on this equation, we identified that this is about linear differential equation. Kalau you tengok dia punya model tu, it is about linear differential equation because it is involving di dt and we have R dan juga kita ada V dekat situ. Okay? Faham tak? Faham Okay, great. Alright. Okay, so untuk jadikan dia dalam bentuk linear differential equation, we need to divided all the terms by L. Okay, kita divide all the terms by L, then here we have Ri over L plus L over L di dt equal to V over L. Then here we have di dt plus R over Li equivalent with V over L. Okay, so the variable involved here is I and T. So kita ada dua variable yang terlibat, iaitu I dan juga T, which is current and time. T is a time. Okay. Alright. So based on this, we can identify for PT. PT is R over L. Apa dia? Ada silap ke? And then QT. So this one yang melibatkan linear, kita ada P dan juga Q kan. So Q of T here is V over L. Then kita boleh cari current at any time T, which is I of T. Okay, faham? Okay. Soalan
Yang PT tu I ke ataupun I ni
tak ada. Sebab I tu is a variable.
Oh.
Okay? Yes. Mana tak nampak?
Oh.
Nak I naikkan atas ke?
Hitam.
Hitam. Mana ni? This one. Yang ni ke?
Yang atas bawah dia dua. Yang gelap je.
Alright. So this one. Okay, kita tengok general form for linear differential equation yang kita dah discuss sebelum ni. Dy dx plus p of xy equivalent with q of x. Okay, so this one is a linear differential equation. Okay, so kita relate dengan application. So this application it is about current ataupun electric circuit. So untuk kes yang ini variable yang terlibat adalah I dan juga T. So untuk yang ini, yang bawah ni yang color biru ni, apa variable dia? Variables. Ya, variable atau variable? Y dan juga X. Okay, so yang ini I dan juga T. Alright, so yang ini penting lah, you kena tahu lah. Sebab kalau you tak tahu, tak faham, susah untuk kita apply. Okay, faham So, apa kaitan dengan yang kali hijau atas ni? Kalau you tengok kat sini, ini kita, this one is a linear differential equation actually. Tapi in the case of electric circuit, which is VR, resistor dan juga inductor. Okay? Betul lah. Okay, so kat sini you kena juga identify for P and Q in terms of current. Okay, so untuk P of T kat sini adalah this one. This one is our P. P of T tak perlu. So I is a variable. Okay. And this one is our V over L. V over L is about our Q of T. Okay. Boleh? Right. So based on this, we need to find the I of T, which is kita kena cari dia punya current at any time T. Okay. So how to find current at any time T? So back to the linear differential equation, we have two steps. The first step, we need to find the integrating factor. Okay, apa integrating factor dia? Semua senyap. Integrating factor.
I.
Mana dah I? Okay. Ataupun exponent integral of R over L. R over L respect to T. Okay, so next baru kita cari Q of I of T. This one kita letak U of T lah, integrating factor. As long as you tahu itu integrating factor. 1 over U of T multiply with the integral of U of T times U of T respect to T. So this is the equation for ataupun the formula for I of T, current at any time T. Boleh? Ada soalan? Tak ada. Berapa lelaki?
Mana you eh? You.
Ha? You.
Oh, you. Yang ni. You dia. Oh, ya, you fikir kita lah. You. Itu je. You.
You. So this one is U of T. U of T ni adalah integrating factor. Kan I letak IT aku sebenarnya keliru So this one is 1 over integrating factor multiply with Q of T. Q of T adalah yang ni. T over L. Okay, times U of T. So U of T is an integrating factor. So how to find the integrating factor? We use this formula, which is exponent integral of P of T. So P of T ni adalah coefficient for I. So coefficient for I is R over L. Jelas?
Jelas.
Very good. Okay, group 221C, any question? Tak ada soalan
Itu UT. Maksudnya tu tapi dia tak lama. Kalau dia ikan biru.
Girls, okay?
Kalau kita warna buat warna buat X kan jadi non X.
Okay, boleh teruskan? Any question, class?
10 plus nanti X dah sebelah tu jadi dah tu. Alright, balik dia ada kena and kan dalam law power kan ni law jadi law lah tengok dulu accent dapat accent batu
Okay, boleh? Alright, so look at this example, example 7. Class, okay? Ada apa persoalan tak? Tak ada. Jelas Okay, very good. Right, so look at this example. Last example for today. Okay? Alright, semangat. Okay, so a circuit consists of 10 ohm resistor. So 10 ohm resistor, so this means that R equal to 10. Okay, it's connected in series with an inductor of 1 Henry. So this one is our L. L equals to 1. So if EMF of the circuit, so EMF apa dia?
Electromagnetic force.
Electromagnetic force. EMF ataupun voltage lah. Total energy. Okay, so if EMF of the circuit is 120 volts, so this one is our V. and the switch K is closed at time equal to 0. So now determine the current at time T. Okay, so bila dia kata switch K is closed, maknanya
Dia on.
ada current tak?
Ada.
Jadi.
Is closed. Switch K is closed. Apa dia? Bukan kosong ke current dia?
Dia berbincang.
Ni betul ke salah ni ayat ni?
Kalau switch close,
Kalau switch close at T equal to 0.
So switch close kami rasa macam ni. Maksudnya kan mula tu
Adakah yang dikatakan kita close lampu tu, switch tu kita close, so tak ada current kan? Tak ada lampu kan?
Plus ni current.
Current ada kan? Ni maksud dia ni.
Dia cakap
What tadi?
tapi kalau
Apa?
kita
KIP kelas. Okay, so if the MF of the circuit is 100 volts and the switch closed at time T equal to 0. So it is instead current at T equal to 0. Apa dia? Tong apa?
Switch close. Buat satu.
Close.
Apa kejadian kat sini? Okay.
Dalam simbol.
Gaduh kan? Tengok. Mana?
Open switch.
Kalau switch close, current ada lah kan? Current ada.
Tengok sebelah dia.
So ayat dia tu?
Tak ada.
switch dulu. Saya tahu lah. Switch.
Apa yang saya faham dengan ayat ni? Dengan ayat ni dia kata switch K is closed at time equal to 0, so means that switch tutup. Bila tutup switch, kita ambil contoh lampu, bila tutup switch tu, so there is no current. Mati.
Budak elektronik.
So there is no current.
Budak elektronik tak ada lagi.
Ada?
Budak elektronik lagi tak ada yang belakang ni.
Oh, ya ke? Ada beza? Ada beza ke juga?
Dia lebih kepada ni yang hitam.
Oh, daripada lintang. Okay. Terus tu masih tak ada nak bagi cadangan ke? Okay, Lan, okay? Okay, so boleh kita teruskan? Okay, so back to this example. A circuit consists of 10 ohm resistor. So this means that the resistor is 10 ohm. It is connected in series with an inductor of 1 Henry. So this one is our inductor, which is S equals to 1. So if EMF of a circuit is 120 volts and the switch K is closed at time equal to 0, so determine the current at any time t. So this question asks you to find current at any time t. Berapa? Okay. So the initial value that it gives to us here is when t equal to 0, so the switch is closed. So bila
Close kosong lah.
dia kosong lah. So maknanya there is no current. Kita tutup
Tak close lah. Tak ada macam ni lah. Kunci kat sini. Ada kat sini. Ada dia. Kita dah habis tadi. Jadi,
Tapi yang penting dia kosong, dia tak mahal kan?
Alright, okay, faham eh?
Dia tidak.
Alright. Okay, so kita selesaikan. So kat sini, based on this formula, Ri over L plus L over L this one, which is this one. Kita guna yang ini So this one we have di dt plus R over L. So R here is 10. 10 over L, L is 1. And I equal to V over L. So V here is 120 over 1. Okay, so based on this, we identified that the equation here is di dt plus 10I equal to 120. Okay, so based on this equation, we need to find current at any time t. Okay, boleh? Apa dia?
Cantik.
Apa Syakir?
Tak boleh bagi lah.
Tak ada. Dah jawab dah tu. Okay. So application ni tak ada dalam test.
Nanti malu-malu dah.
Saya akan bagi assignment untuk application saja.
Oh, dia tak ada test.
Tak ada.
Oh, ni saya.
Ni assignment.
Ada close itu, pasal close.
Final ada. Final ada.
Ini lagi pula.
Okay. Alright, so I ambil terus yang ni equation yang ini. So here we have di dt plus 10I equivalent with 120. Okay, so this one is a linear differential equation. Okay, so here we need to find, identify for P and Q. Okay, selesaikan ni. P of T. P of T equal to 10. This one is a P. This one is our Q. Yep. 120. Okay, so first we need to find integrating factor. Okay, exponent 10t. And then second, kita cari I of t, which is the general solution. So I of t, current at any time t, it is equivalent with 1 over integrating factor multiplied with the integral of 120 multiplied with u, bukan ux salah ni, ut. Variable the t. ut respect to t. So it is equivalent with 1 over exponent tan t multiply with 120 exponent tan t respect to t. Okay, so selesaikan. Apa jawapan dia? (120) exponent tan t. So yang ini you differentiate. Dia akan jadi division. Plus C. Salah apa pula ini? Nampak belakang? Twelve exponent tan t plus C. So this one you boleh multiply. Then kita akan dapat apa tu? 12. Betul ke ni? Ada silap mana-mana ke ni?
Tidak
Bawa sikit. Tak, doktor tengah cek.
Kita kena tengok balik question kita. F 100 which k close at t equal to 0. R over L then 120 volt. Okay, cuba tengok pada atas. So this one is our equation. Then I 120. So integrating factor exponent p of t dt. So p of t is 10 t exponent integrate 10 t, we have 10 t lah, exponent 10 t 120 multiply with exponent 20. Okay, so this one we can simplify. Then we have 12 plus C. Okay, divide. Kita integrate exponent 10t, we have exponent 10t over 10. Plus C. Oh, tak hilang. Ya, plus itu dalam ni. You integrate this one. Gitu. Okay, so you integrate yang ni. Kita integrate yang atas ni. Integral of 120 exponent 10t dt respect to t. So we have 120 exponent 10t over 10 plus c. Okay, so bila kita multiply with 1 over exponent t. So this one we multiply with this one. Then we have 12. And then this one, yang ini kita multiply dengan second term, C. So here we have C over exponent 10t.
Oh.
Okay, faham?
Ah.
Alright, so we have initial value so that we can find C. So the initial value here is when t equal to 0, so there is no current because switch K is closed. Okay, so we substitute t into 0 to find our C. So here we have I at t equal to 0, 12 plus C over exponent 0. 10 times 0 is 0, okay? Equal to 0. So C negative 12. Betul? Therefore, current at any time t is 12 minus 12 over exponent 10t. You ganti kasih dalam. Alright, boleh? Ini dah jawapan dia. Group 2221C, any question? Tidur ke? Firdaus faham?
1, 2, 10 orang.
10 orang. 8 orang mana? 18 orang.
Faham dia.
Faham eh?
10 orang saja.
Ain, Syamila, okay? Alright. Marsha, semua okay ya?
Okay.
Alright, okay. Dah, siap. Okay, so this is the time t here is 12 minus 12 over exponent 10t. So katakan you nak estimate untuk current after 10 minutes, you just substitute t into 10.
Oh.
Okay?
Lagi dah faham.
After 10 minutes.
Yes, so you can estimate. You boleh estimate lah. Alright, so kalau tak ada apa-apa soalan, that's all for today. So untuk next week is cuti.
Kamis.
Berapa ada kelas? Seberapa? So after break baru kita masuk second order. Okay. Kita harikan chapter 4. Yes. Apa dia? Yang ini nanti saya share dalam group sebelah. Apa yang ada salah?
Tadi kata tak ada soalan. Dalam nanti nak tanya.
Tengok atas ni. Boleh.
Kali kelas tu dah tutup mulut je. Jadi tak kata.
Okay, so ada mistake sikit Buka balik.
Guys,
Okay, so this one kita integrate and then plus C. Okay, so darab kat sini, so dapat kosong. Ada C kat sini kan? So this one kita multiply dengan this one. So here we have 6C over 10 squared equal to 0. So jawapan dia is still 0. Betul? Kosong lah. Dia bawa 10 squared ke sebelah ni pun dia akan dapat kosong. And then C 0 over 6 equals to 0. 0. Sama je. Right, boleh? Okay.
Yeah,